Okay, welcome to this little example on case-based reasoning, or rather explicitly how to use myCBR using Java. Okay, so here what we have is a little book trading example where you put your book title, year, a category, an author and an award, and want to query the system and look for similar cases. So to gain an overview on a bigger picture, you have here the interface, the JSP data, the formula where you send the content to the book servlet. In book servlet you fetch the data, you pass some data which is a string. For example, here the input year is obviously not a string, but we need to catch it as a string at first, and then we will pass it as an integer and pass Boolean for the award, since it's yes or no. We build our own book, our own data type, and then we are getting to the interesting part of myCBR. We save our results of myCBR to the request, and we send the request back to the index JSP, and here we will later put our results. So we have our own data type, a book, which is basically consisting out of the attributes in the formula. And we will have here our agent, which is not a Jade agent, but here just a normal Java class. But this is the bigger or the raw overview. So again, we will begin at the index. So on this page, as I said, we have this formula, and we will send through the submit button, we will send our data to the book servlet. You fetch the data, and we create our own book type, data type, and we will send this to the book agent. So the book agent in its constructor starts to build a project and a case base. We begin with the project. So here we will just have a new project, and if you mouse over here, you can see it's from the package dfki myCBR core project. So this is coming directly from myCBR. So we have here a myCBR jar file, a library with everything that you need for myCBR or for CBR in general. This is available in LearnWeb, so you can just simply download it and be sure that you save it in web content, webinf lib. So here we use Eclipse IDE, which is free to use and easily to install. So we set a name and an author. This does basically nothing, just organizational things. But here we create a concept in our project. So this is basically an object which will summarize all those attributes. And here we begin to define the global similarities. So we define an amalgamation function. We configure it with the weighted sum. If we delete this here and put control and space, we can see other amalgamation functions like maximum, minimum, or Euclidean distance, which we can also use. We give the function a name, and we say that we actually want to use this function. So we set this to true. Afterwards, we define our local similarities, so for the attributes per se. So here in the global similarities, in the amalgamation function, we define how important is a book title, how important is a year, how important is a category. We use this attribute here, as you can see it highlighted with set weight, title, author, category 2, 3, 4. So you see the category is more important than the title, for example. So these factors are going into the weighted sum. For local similarities, we have here, for example, a string function for the title. So later we will put some kind of title into the text, and we will need to figure out for similar strings. So we need to figure out how to measure similarities between strings. And here, as you can see, we have a string config dot Levenstein. So this is basically using the Levenstein distance, which says how many characters do I need to correct to get from string A to string B. And again, if you delete this here and put control space, you can also see we have here a string config function for equality or n-gram distance, but here we will use Levenstein. We give it a name and we set it active. The same for the author. The more interesting part is coming here with symbol. So in symbol, we don't have simply just strings, but we have a selection of different attributes. So we have, for example, drama, we have comedy, we have thriller, and then we define how similar is comedy to drama. So here we say comedy to drama is 40% similar. We define comedy to thriller as 20% similar. So here we have a similarity matrix which we define by hand. And explicitly here we say comedy to drama and we say drama to comedy. So we don't just expect we don't expect that the similarity is valid vice versa, but it's that we explicitly define the relationships. Again, we set the global similarity, so we say how important is the category. And for the integer, we have a function which we add to our concept. So as you can see, every local similarity we add to our concept, which again in the beginning was our object which will hold everything together. We give it a name, we give it a minimum, we give it a maximum, and here we say a number config as we had before the string config. We have a number config, so we say polynomial width, so basically a curve. We could also go delete this here and can say we have a constant, we have a smooth step at a certain value. But here we go with polynomial. We set the parameter, so we are saying to the right side it should decrease by a factor of 2, and to the left side the same. So here we have on both sides the same similarity. But again, here you can also imagine that, for example, if you are querying a page for a car and you are querying with the price, or your price is at least or at maximum 15,000 euros, then you can say, okay, maybe I am willing to pay a little bit more, maybe I'm willing to pay 1,500, 500, but then decrease the similarity because it's not like what you explicitly want. But on the other hand, if the car is cheaper, then you wouldn't mind or you wouldn't bother if the similarity is still the same. So you don't want to decrease the similarity if the price is lower. And Boolean is basically nothing surprising. You just add the function and the rest will do the API, since it's just true or false. So this is for initializing a project, and make sure that you have the rights to write on this project, which will come in the next step. So we initialize a case base. So here we create a default case base, we give it a name, and here we add cases. I will come to this in a second, but this is also the important part. XML exporter.save project, data path, and project name. So here on the data path and project name, here we have just basically the disk D and the booktrading.prj, the project file. Be sure that on this path you have the right to write there, otherwise you will get here an error. So after the case base has been initialized, we add some cases to it. So here you can see the first instance adds City of Bones, has been published in 2017 by Cassandra Clare, which we define as a drama, and we say it has won an award. I'm not sure if that's actually the case. And here you can see more cases are added by hand. And as you can see, this can become a tedious task. For example, if you have like thousands of cases. Obviously, you don't want to do this by hand, but rather import something from, for example, an XML file, a CSV file. So somewhere you want to extract data from and import it here and add it in a loop as instance to your case base. But as a proof of concept here, we basically just do it by hand. So this is it. What happens when a book agent becomes initialized. So we go back to our book agent. So everything what we have done with myCBR here has been triggered by creating a new book agent. Afterwards, we use our objects and we start our query. So our query book is the book which will be inhabiting the contents of the formula. So we start a query. To start a query, we define some descriptions, and then here we start the retrieval, and we say the retrieval method is retrieve sorted. So we already gain a sorted list of similar cases, which we will use in a second. We start to query our instance, and for the query we add the attributes which we have stored in our book object, which again has been defined in a servlet and uses the attributes which have been typed here in the formula. If everything has been passed successfully, we start the retrieval and we get the result, which returns a list of pairs of instance and similarity. So slowly, this is a list which has pairs of instances and similarities. Instances here are cases. So we have cases and we have the similarity to our query. And since we don't have just one case, we have a list of those pairs. So nothing too complicated. Just think about it. After we have done our query, I will go back to the servlet. After we have stored everything in our list, we give this list to the print function and we give it also a 5. So we want to retrieve the 5 similar cases here in the print function. The print function, as the name says, basically just prints. So we create a list of books, an array list which contains book objects, and as long as we have the number of best cases, so in our example 5, we go through the list of our results, and here we get an instance. So we have book concept, we get an instance, and we gain all the attributes out of this instance and save it in our book object. We add our book object into our list of resulting books, which we will iterate through in a second. And here we just output the case and the similarity. So going back to the servlet, we have printed our results, or basically we have stored our 5 best cases into this object. This object becomes saved into the request. And going back to the index.jsp, as I said before, we had here the formula, which you can see here. You have a horizontal line, which you can see here. And then if resulting books isn't null. So at first, during initialization, resulting books is obviously null. But if we have started a query, it becomes unequal null. And then we can go and iterate through the list of resulting books. So here we go use the JSTL, the custom tags, and loop through our list of books. We rank it through, and since our retrieval was ordered, we can rank it here directly. we print the similarity and all its attributes. So at first we don't have any clue what is in our K-space. Well, as maintenance engineers as we are, obviously we know what is in the K-space because we can basically just look it up in the agent. But we can also start any queue here. So the book title is Bob is going for a walk. The year is 2021, since Bob cannot do anything else outside. And the author is Bob Bauer. And it obviously has been awarded. Start a search. Don't get irritated by the error messages, that's just normal. And our most similar case is City of Bones 2017, a drama, and with 52 similarity. Okay, we didn't expect it actually to find this book, right? But to prove that our CBR system is working correctly, at least we want to find, we assume that if we find explicitly look for City of Bones, we should find it with 1.0 similarity, right? So we insert all the data, the City of Bones, the year, the drama, the author name, and it has been awarded true. And we search, and as to be expected, we find it with similarity 1.0, but then we are looking for the other cases, for the other ranks. So we have here 65, 65, 63, 61. So, but these cases are really distinct to each other, right? So the title is very different. The year is different, where we queried for 2017. So here we can see if we have another year that decreases in the similarity. That's correct, but it's not like, it's like just 2%, and it's here just 4% compared to rank 2. So here's basically your task if you want to think about this, go into this project and think about what should I now change. So if I'm going back into our modeling, should I change the local similarity here? Should I change how much I want to punish if the year is different to what we queried? Or should I change the importance of the year attribute at all? Should it be more important? Should other attributes be more important? And this is the interesting part in myCBR, or the challenge to find the right similarities, to model the similarities as you want to, as you would expect your system to work. And this is where also the human component comes in. So this is where you define how you want your CBR system to work. So this is it as a brief overview on how to use myCBR. There will be some tutorial slides added in the Learn Web, and if you have any questions, feel free to ask. Send me an email, write a comment, or rather send me an email. I will rather see emails than comments here. And yes, have fun, try it out, and write what you think. Thanks for your attention and have fun.